do is I'm going to take my LDR here, my light dependent resistor, and I'm going to place this in the breadboard. I'm going to place it over here, and I'm going to put one leg into row 1 and one leg into row 3, like that. And then I'm going to take a 1 microfarad capacitor here, and I'm going to place the long leg of my capacitor into row 3 and the short leg into row 5, so it's in series with the light dependent resistor. So when current flows through the capacitor, it's going to have to flow through the light dependent resistor first. I want current to flow through the LDR and the capacitor. So on row 1, I'm going to place a jumper lead, and that's going to go into the 3 volt output on my Pi there. And then from the capacitor's short leg, that's in row 5, I'm going to run that into any ground pin. So I'm just going to pick this one here, like that. And the last thing to do is to come from row 3 here on the breadboard and run that out to one of my GPIO pins. So I'm going to choose GPIO 4, which is this one here. Now we can go and encode this and see if we can detect some light. To get started, I'm going to come to my menu, come down to programming, and then choose Python 3 idle from the menu. So my interpreter's opened up. Just resize this a little bit. And then I want File, New File. Now we have a window to run my programming. So we're going to start off by importing the GPIO0 library, and we want the light sensor from that library. So we'll go from GPIO0 import light sensor. Next, we want to tell the we need to set up our light sensor. So I'm going to say LDR equals light sensor 4. Now I can go ahead and save and run my code. So we'll file, save as, we'll call it LDR.py, save it, and now I'm going to run it by hitting F5. Now I'm going to run it by coming up run module. Now I'm going to shift over into my interpreter and see what readings I'm getting from my LDR now. So if I type LDR.value, it comes back and tells me there's a value of 0.86 at the moment. What I'm going to do now is I'm going to shine my laser onto the LDR and find out what the value is this time. So here we go with the laser on the LDR, and I get a value of 0.92. So there's not much differentiating those two values at the moment because my LDR's in the light, just in the room that I'm in. So we need a method just to reduce the amount of light that's getting to my LDR. To try and get my LDR to detect 0 light or very little light at normal levels, I'm just going to cover it up. So what I've done here is I've taken a length of a drinking straw, and I'm just going to pull my LDR out of the breadboard, and then I'm going to insert the LDR into the tip of the straw, like that. Give it a bit of a push in. So now my LDR is covered up and it should receive a little bit less light from the sides. I can now place it back where it was before. So it's in rows 1 and 3. Like so. And now I can run my code again and see whether I get different light levels when the LDR is being illuminated by the laser and when it's not being illuminated by the laser. So let's see what happens now. I'll do LDR.value again, now that the straw's over. I get much lower value because less light is getting to the LDR, which is changing its resistance. I'll now shine my laser down through the straw, and we're back up at that 0.9 sort of level. What I'm going to do now is I'm going to add a buzzer into my circuit so that when the light beam gets broken, the buzzer will sound. So I'm going to take a buzzer here, and I'm just going to place this into my breadboard. And I'm going to place it on row 15, so that's the long leg into 15, which means the short leg is going into 18 here. And now I'm going to take a couple of jumper leads, go from 15 there into one of my GPIO pins, and I'm going to choose pin 17, from 18 here into another ground pin. There we go. Now we can go back to our Python script and we can include the buzzer in our program. So we want to start off by importing the buzzer as well. So go up to my first line here, and I'm going to put a comma in and then type buzzer. And the first thing I want to do is I want to test that my buzzer's working. So down here, I'm just going to say buzzer equals buzzer, then tell it which pin it's on. I put it on pin 17. So I'm just going to save and run this again so I can test that my buzzer's working. Save and run module. And then over here in the interpreter, I should be able to just type buzzer.on and buzzer.off. So to code this to include my buzzer, the first thing I need to do is grab the sleep from time. From our time, import sleep. Next two lines stay the same. Now I'm going to start up an infinite loop, so while true. Now if I just constantly ask what the LDR values are, they're going to shift all over the place because the program's going to be asking at such a high rate because it's going to run so quickly. So I'm going to actually slow my program down a little bit by putting a sleep, and we'll go for 0.1 seconds. Then if the LDR value, and we'll say if it drops below, let's go for 0.5. So if the LDR value, the reading of the LDR, ever drops below 0.5, we can turn our buzzer on, buzzer.on. And if it's above 0.5, we'll turn our buzzer off. And there we go. So that's my completed program. Now we're going to see whether this works. So I'm just going to save it. So here we go. I'm going to run my program, and the buzzer comes on. Now if I shine my laser down through the torch, we can see the buzzer goes off, and every time I cover it up with my finger, the buzzer comes back on again. So we have the basic laser tripwire working now. We just want to package it in a slightly better container. LDR, and my capacitor out of the breadboard now. I'm now going to connect them together by taking my capacitor, taking the long leg and one of the legs of the LDR and place them into the same end of a female to female header cable, just like that. Now I want to tape them together a little bit just to keep them secure. So I'm just going to wrap a little bit of tape over the header lead and over the legs of my components. And there we go. Now I can take two more female to female header cables, and one's going to go onto the leg of the LDR and the other one onto the other leg of the capacitor. And now I need to just wire up my buzzer. So same with the buzzer. I take my buzzer and I get a female to female header cable and place on one leg, and then another female to female header cable and place that on the other leg, like so. And I'm good to connect it all up to the Pi. So the LDR capacitor combination, that leg of the LDR, I'm going to place that into my 3 volt there. The middle jumper lead, that one's going to go into pin 4. So 1, 2, 3, 4. So that's in GPIO 4. And then that final one into one of my ground pins. So I'm going to put that back into this ground pin just there. And then for the buzzer here, so the long leg, that needs to go into GPIO 17. So 4 ground 17 is just there, and this one into one of the ground pins, one next to it there. Okay, so now that's all wired up and I'm ready to put it in its housing. Just a plastic box. Okay, and I've taken my Raspberry Pi and I've connected it to a battery here. Okay, so that's going to run independently, and inside the plastic box I've just put a little hole here, and that's so my straw can poke through that hole just like that, and that's where I can now aim my laser, and I can place the whole lot all under the box like so. And now all I have to do is fire the laser down this hole, and if anything breaks the beam then it should go off. So let's just test this and see whether it works. The laser pointer gaffer taped to the skirting board, and if we look over here I've got my Raspberry Pi sitting in its box with the straw sticking out there and the laser pointer shining into that. If you want to make sure that the laser's there, what we can do is we can turn the lights off, and then we can blow a little bit of flour. We can just about see the laser. There we go. We can turn the lights back on now, and then we can get some unsuspecting person to walk through the laser and set it off. And then when they walk back out again, and we can see whether it works with dogs. Loki, come. Yes, it works fine with dogs as well.